My dear students, today we will discuss few more concepts related to second module of signal system. So far, we have discussed all the concepts which are there in the first module. Everything we have discussed, and also in second module we have discussed about the convolution sum, convolution integral. We have discussed all these concepts. I have made video lectures on the convolution integral, convolution sum, everything. I have made video lecture on this. Today we will discuss the properties of LTS systems. Here so many properties of LTS systems are there. Those properties are here. The given properties of impulse response representation of LTI systems. Here, there are so many properties of LTI systems, mainly commutative property. So many different properties are there. We'll discuss one by one what is this property. That is, first we'll discuss about the commutative property. Commutative property. In this property states that convolution is a commutative operation. Commutative operation means suppose A into B is equal to B into A, then it is called as commutative operation. Suppose A plus B is equal to B plus A, then such a equation is called as commutative in nature. Like here also, that is, here we will tell that this property states that convolution is commutative operation. Means whatever we have done so far, we have discussed about convolution integral. We do convolution integral on what? The continuous time system. Here they tell that the convolution is a commutative operation. Means x of t into h of t is equal to h of t into x of t. That is, if you interchange the positions of the input and the unit impulse response, then there is no change in the output. Now we will here they have they have derived that one. That is how that is convolution is a it works as it will obey the commutative operation. For example, we already know that for continuous time signal the convolution integral is given by y of t equal to integration of minus t to infinity x of tau h of t minus tau d tau. Here what we have here 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 what suppose to prove that one, that is the convolution integral is obeys the commutative property. Here what we'll do, first we'll take that is y of t output, y of t equal to integration of minus infinity to plus infinity x of tau h of t minus tau d tau. In here what we'll do, we'll put t that is t minus tau equal to m. We place for proof of that, proving that the convolution integral obeys the commutative operation. Therefore, for that what we'll do, put here in this equation, put t minus tau equal to m. Therefore, then what happens? Then do the integration, differentiation of that. When we do the differentiation of tau, then it will be d tau equal to minus dm, because when we do the integration, then it will be like this. And here d tau equal to why, because if you rearrange that one, then tau is equal to t minus m. Therefore here t will be works as a constant, and we are differentiating with respect to m, then it will be, equation will be d tau minus dm. Then what happens? Then when tau is infinity in this equation, when tau is infinity, here in this equation tau is infinity, but here m will be minus infinity. Why? Because d tau equal to minus dm. Therefore, tau is infinity, m equal to minus infinity, tau equal to minus infinity, then m equal to infinity. Opposite, because d tau equal to minus dm. Therefore, the limits of integration will be also interchange. Therefore, when we substitute the value of that is what that is t minus tau equal to m in the above equation, then what happens? That is y of t equal to, substitute in this equation, then y of t equal to minus of y minus, because d tau here in this expression we are having d tau. That at that time, suppose substitute the value of d tau as d tau equal to minus dm. Therefore, minus take outside, then limits of integration will be plus infinity to minus infinity. Why? Because when we have taken tau as infinity, m becomes minus infinity. If tau is minus infinity, m becomes opposite, because here when we substitute the value of tau as t minus tau equal to m, then we'll get this like this. Therefore, this above equation becomes y of t equal to minus integration of plus infinity to minus infinity. Here integration limits are how the limits of integration minus infinity to plus infinity. But here what are the limits? Here the limits of integration are plus infinity to minus infinity. X of tm, x of t minus m. Why t minus m? X of tau is there. Here what we have taken, x of tau. What is the value of tau? That is, I told that when t minus tau equal to m, then tau will be equal to t minus m. Therefore, in this expression tau, we have to place what? T minus m. Then h of t minus tau. When we use that one, then t minus tau, what we consider? M. Therefore, it becomes h of m. Then d tau will be equal to minus dm. Minus dm, therefore dm, this minus we have taken this outside. Therefore, these equations become like this equation. Y of t equal to minus this equation, this y of t becomes minus integration of minus infinity plus infinity to minus infinity x of tm into h of m dm. Then what happens? Minus is there. Suppose we interchange the limits of integration, then what happens? If we change the integration of limits of integration from plus infinity to minus infinity, then what we have to do? We have to take minus, then integration of minus into plus infinity. When we take minus, then already minus is there. That minus, this minus into minus, it becomes plus. Therefore, here in this equation, you don't have this minus here. You see here, because you have changed the limits of integration. That is minus infinity plus infinity, x of tm, h of m dm. Therefore, we rearrange this one, then this take h on this side and x of tm this side, then dm. Integration of minus infinity to plus infinity. This is what? This here m is some variable. Since m is just a variable, we can write a tau. Instead of m, we can write a tau. Just for the proof of that, here we have taken tau. Here we have taken m. Suppose in place of m, you take tau, then this equation will be same as this equation, but it will be h of tau. Then it will be integration of h of t into x of t. That is this you see here. Y into integration of h of tau x of t minus tau d tau. That is nothing but you see here h of t into x of t. Therefore, this we can tell that y of t equal to x of t into h of t. This is your x of t into h of t. This that we can elaborate this as integration of minus infinity to plus infinity x of tau h of t minus tau d tau. Therefore, here you see here we have derived that we can see this from this we have derived this. It we h of y of t equal to h of t into x of t. Both will be same. That is, we can write x of t into h of t or h of t into x of t. Means this convolution integral will obey the commutative operation. That is, a plus b equal to b plus a, or a into b is equal to b into, like this. This is x of y of t equal to x of t into h of t equal to h of t into x of t. This is about how you have to, we will prove that this integration, convolution integral obeys the commutative property. Similarly, you have taken here convolution integral. Here also we can take that is about convolution sum. Even the convolution sum also obeys the commutative property. Here you see this one here, x of n into h of n is equal to h of n into x of n. This is nothing but, what is this? This is also, that is yeah, here this equation shows that discrete convolution is also commutative. This discrete convolution is also obeys the commutative operation. Like this is how the properties of impulse response representation of LTI system. That is, properties of LTI system. In that, one is commutative property. Next, sometimes they ask, then you have to derive all this. You have to prove that one. That is how the LTI systems, properties of LTI system, how they will obey that is commutative property. At that time, you have to derive all this, how it will obeys the commutative property if taking convolution integral or convolution sum. Next, cascade connection of LTI system. When we connect systems, suppose x of t, which with if two systems we are interconnected, cascade connection of system. Suppose we connect two systems. This is one system. This is another system. This system input is x of t and output is y1t. This y1t will give as an input to the next system, and this is the output of these two systems. And here H1 and H2 are the impulse responses of two systems. Then what happens? What will get that one if we cascade or interconnected two systems? Then what will get? That is y of t equal to y1t into h2t. Here the output here. This is what here. This is the system. This is the for this system input is x of t, output is y1t. But to this system output is this. What is input? y1t is the input, and this is therefore y of t equal to y1t into h2t. That is integration. Sorry, convolution is that what this is, y of t equal to y1t convolution. That multiply a star sign indicates that is y1t into or convolution of y1t into h2t. This is nothing but convolution integral of the input and the impulse responses. That is y1t into h2t. That also we can write this as integration of minus infinity to plus infinity y1 tau. Here previous what usually we take x of t, but here since this is y1 is the input, therefore we have taken this as y1 tau, and this is h2 t minus tau d tau. This is how we have taken this one. Then that is the output of the first system. Here this is the output of the total output of the system is y of t. Y1 is the output here, therefore you got this. But y1t, what is y1 here? If you see here y1t, here what is the expression you will get y1t? Y1t equal to integration of y1 tau equal to x of tau into h1 tau. Therefore, that we can write as integration of minus infinity to plus infinity x of m h of tau minus m. Alright, because we have taken the expression, therefore we will take one more variable so that we can avoid confusion. Therefore, we will take this as one more variable m. Then this will be the output of the convolution of this output is equal to integration of minus infinity plus infinity x of n h of tau minus m dm. Then what is the total? This equation y of 1 we substitute in this equation. This what equation number is what? Here they have given the number. This equation I am telling. This equation in here in this equation. You substitute the value of this y1t. Then that becomes, already this is integration is there, and substitute the value of y1t here, double integration. Therefore, y of total output y of t equal to integration minus into plus infinity, integration of minus into infinity plus infinity x of m from here. Then h2 is here, h2 t minus tau, h1 and h2 minus t, sorry, h x of m x of m h1 tau minus m. Then here we have substituted here. Then one more term left here, that is nothing but h2 t minus tau, h2 t minus tau. Here dm is there, here d tau is there. Therefore dm d tau. Then this is here, put the value of tau minus m equal to n. Then from this we'll get that one. So we will go on deriving. Then we get that is when we give the input, when the two systems are connected, then we'll get the output as y of t. That is h of t is the nothing but h1t into h2t. When two systems are connected in series, when I connected two systems, then total impulse response is equal to h1 into h2 h1t into h2t when the systems are two systems are connected in series. Like here they have given that is how we have derived that one. These are the properties. At that time we have to explain all this. Usually they will ask the problems related to this, that is the cascade connection, or whether the system, some conditions are there, whether the LTI systems is stable or not, causal or not. Usually they will ask problem, but you also have to know the properties of how we will obtain the properties of the properties of LTI systems. Here suppose two systems connected in parallel. This is one system, which is one system. This is second system connected in parallel. Then we will get this is nothing but this is the expression how we will get x of tau equal to h1t plus, here we will get the expression h1t plus h2t y of t, where h1t and h2t are the impulse responses of these two systems. It is when it becomes plus when they are connected in parallel, they become multiplied when they are connected in series. This is some properties of LTI systems when they are cascaded, when they are connected in series and in parallel. Some problems are there. Afterwards we will solve some problems related to how the system, whether the system is stable or not, whether causal or is it commutative. Like this, so many problems will solve related to the LTI system. Causality of LTI. What is the condition that is the system will be causal if they will give an equation of a LTI system and ask you to determine whether the system is causal or not. At that time you have to condition for that is what here. The LTI system is causal if and only if h of n equal to 0 for n less than 0. If this condition obeys, then we can tell that the system is causal. A LTI system is causal if and only if h of n equal to 0. Like that, they will ask, this is the necessary and sufficient condition for causality of the system. Already in the properties of the system, we have discussed what is causal, what is non-causal systems. That is This is how so much derivations they have given. Since they have not asked for you in the internal, therefore I am not discussing in detail about that. And also we are not having enough time to discuss all these properties of the system. For a LTI system to be causal, h of t equal to 0 for t less than equal to 0. Then if t is less than 0, then equation of convolution will be equal to y of t integration of 0 to infinity. But here we will not discuss about minus infinity plus infinity. Since it is for causal system, we can modify the integration limits as of convolution as integration 0 to infinity x of tau h of t minus tau d tau. Next, we will solve some problems related to determining whether the system is causal or not, stable or not, stability of LTI system. Here they have given some how derivation of the stability of a LTI system. The condition is what? If suppose we want to find out whether the LTI system is stable or not, then this is the condition. That is summation of k equal to minus infinity plus infinity modulus of h of k is less than infinity. Then this system we can say that this is stable system. This condition is for the system, those are discrete in nature because summation is there. Therefore such equation is for discrete system. Similarly for similar for continuous time system, the equation is what? Here integration minus infinity plus infinity modulus of h of tau d tau. If it is less than infinity, then we can say the system is stable. If the above condition is satisfied, then the system will be produce bonded output for bonded input. This is called Bibo stability. Bibo means bonded, the system which produces bonded input, bonded output, then that systems are called as stable systems. That is for continuous time signal integration of minus infinity plus infinity modulus of h of tau d tau. If it is less than infinity, whatever equation will get, whatever the result is get, if it is minus less than infinity, then we can tell the system is stable. Next, we'll solve problems related to in internal also. In question bank also we have asked that determine whether the following system are stable or not, causal or not. For that time you have to know these equations. Whether to find out for continuous time system, you should know this equation. For discrete time, you should know this equation. This is the equation for whether the system is stable or not. Like so many properties of the system are there. One more, memoryless and memory properties. Memoryless with memory systems. Here also the condition for memoryless, that is h of n equal to c delta n. Here c is arbitrary. Similarly, condition can be derived for continuous time system. For continuous time system to be memoryless or static, its impulse response must be of the form of unit impulse. That is h of tau is equal to c delta t. Delta t is what? Unit, that is impulse, unit impulse. Impulse means that is, this is h of n is h of t is what? Impulse response. Whereas this is delta, whereas delta t is what? That is unit impulse. What do you mean by unit impulse? Means it is only impulse, a particular, here you see for delta n equal delta n, it is impulse signal, unit impulse. That is at t equal to 0 only particular sample, particular signal exists, and elsewhere if t is not equal to 0, then delta t is equal to 0. Already while discussing about the various types of signals, we discussed about unit impulse signal. Unit impulse, that is nothing but delta t. which exists only at a time t equal to 0. One signal exists at time t equal to 0, and no signal is there when t is not equal to 0. Means towards x-axis, time axis, right side or left side, there is no signal. Only at the origin, only at t equal to 0, we are having a single signal, that is delta t. We call that is unit impulse. Here h of t is what? That is, if for system the input is the unit impulse, input we give, what output we get, that we call as impulse response. H of t is what? It is output of to the system. Suppose we have given the unit impulse, then we get the to this output, that output we call as h of t. That is nothing but it is an impulse response. Then these are the conditions for system to be memoryless or static. Then this condition h of n should be equal to c delta n, where c is arbitrary constant. Here also c is some constant. Then h of t is equal to delta t, h of n equal to delta n, to the conditions for the system to be static or memoryless. If it is not there, then system is dynamic, or we can call this system is with memory. Already we know the static and dynamic systems. These are the conditions to know whether systems are static or dynamic. Then invertible systems. Invertible systems means, here in the condition for invertible systems, that here this is thus the convolution of any signal with unit impulse gives, and here that is h of n into, if a system is, when we call the system is invertible, means when we some system is there, this system is there, we give the input and its impulse response is h of t, y of t is there. Suppose we connect one more system whose impulse response is inverse of that. That is, if it is h of t, then its impulse response is h of minus 1 t. Then the output is what? X of t. Whatever input you have given, the same output will get. Whatever input we have given, suppose we'll get the same output, then this system is called as invertible system. If the output is here is different, the input is there here different, then such systems are not called, that is invertible systems. Only if this will this is h of t, when we combine with another inverse system, then output is same as input, then this such systems are called as invertible systems. Invertible systems. Therefore, here, then what is the condition? That is h of n into h of raised to minus 1 n is equal to delta n, or this is how we will find out the convolution of any signal with unit impulse gives. Like, this is the condition whether system is invertible or not. H of t into h of minus raised to 1 t equal to delta t. These are the conditions to know whether the system is invertible or not. Like, such properties are there related to LTS systems. These are the properties of LTS systems. Next, what we'll do, we'll solve some problems related to these properties of LTS system. Usually what in exam, what they will do, they will give some equations of LTS system, then ask you to find out whether the system is stable or not, causal or not. Then what you have to do, using the conditions, you have to analyze that whether the systems are causal or not, stable or not. You have to identify that one. In internal also, in question bank also, we have given some equations of the systems. both for continuous time signal and discrete time signal, and asked you to find out whether the system is stable or not, whether they are causal or not. That one only we ask. But even though sometimes what happens in exam, they will ask derive the properties of the LTI system. That is whether how you can prove that the LTI systems obey commutative law. Like this they will ask. At that time we have to derive these equations. Like this, these are some examples. These are the properties of LTSS. Next we will discuss about such problems. How here they ask, you see here, verify whether the following systems are BIBO stable or not. They will give such problems. At that time we have to find out whether these systems are stable or not. In next video lectures, I will solve some problems using such problems. I will explain whether the system are stable or not, causal or not. In next video lecture, I will explain all those concepts. Okay, these are the properties of LTS systems. Suppose you want to know in detail about that one, refer the notes. Already in notes I have written everything very neatly, correctly, and all the properties I have written. Please refer my notes. Okay. Okay, thank you.